So our sun, which is a star, is basically just a huge nuclear reactor. There is a lot of energy, a lot of heat, a lot of light coming off our star, the sun, that the Earth gets and uses. So as we take a look at how our energy needs on our planet continue to rise, it only makes sense that we go to the biggest nuclear reactor that we have. In this video, we're going to talk about solar energy and some other forms of green or renewable energy that we have available for us today. Let's get started. So as we talk about energy use on our planet, I pulled this graph because it shows you the increase of energy used over the past few decades, starting in 1990 all the way up to 2020, 2023, where we are today. Few things to note. First of all, this chart is actually in the millitons of oil equivalent, right? And what you see is that this trend globally is on the rise. So as we know, we were a little below 9,000 million tons. Now we're closer to 15,000 millitons. Well, where has the growth been? A lot of people think, well, it must be in the United States. Well, if you look for North America here, this lighter blue, we've maintained relatively equal consumption of energy, surprisingly, throughout these past few decades. What you see is the real growth is taking place in Asia, okay? So this trend will continue to go up, right? We're not going to all of a sudden start using less energy, right? It's only going to continue to go up, in my opinion. So we need to be thinking about ways in which we use our energy more efficiently. So in this video, I want to talk to you about some of the green or renewable energies available. This is just an introduction to this topic to get you familiar with a few of the terms. There will always be many more things that we could talk about that we just aren't going to get to in this short video. But I want to start by talking to you about this idea of green energy or renewable energy. And a lot of times this renewable energy is also cleaner energy. So why are we concerned, of course, about green energy or clean energy? Because as you know, climate change, if you watch my video on climate change is being caused by human activities, specifically CO2 or greenhouse gas emissions, as well as some methane and nitrogen emissions. So as we continue to need more energy, we don't want to necessarily be making our energy through the burning of fossil fuels. So we need a more renewable energy, a cleaner energy that's going to help us meet this new growing energy requirement on our planet. So what I've done here is I'm going to give you several of the main types of green or renewable energy that we're going to talk about. All right, so wind energy, I'm going to go in more depth than that. Ocean energy is, to me, a really untapped potential, because if you think about it, there are waves in our ocean, right? There's a lot of movement. There's a lot of potential energy in our ocean that, right, we don't have to put in any energy to get. So basically, there's all of this potential energy from collecting the movement of waves. And I think this is really some untapped potential that maybe we'll see an increase in. Geothermal energy is harnessing the power of the heat coming from our Earth, from our geo, right? And you'll see that in places where it might be close to some really like lava, some really hot geothermal springs. Hydroelectric, we've been using this for many years. Hydroelectric meaning getting our electricity from water. So where you see dams built that are harnessing the power of that water flow, like you might see if you were to visit Hoover Dam or the Three Gorge Dam in China. Solar energy, of course, is the other big one that I'm going to talk about today. Solar energy is really on the rise, as you'll see here in a chart I'm about to show you. And really, solar and wind, in the United States at least, has seen a huge increase in its ability to provide us energy for our daily lives. All right, so this is an overview of several types. In this video, I'm going to focus on these two, and I'll show you why here. So, from 2010 to an estimate of 2027, these are some renewables energy trends that you might see. This was published as part of the International Energy Agency to show us some trends that we see. All right, so one of our main ways to get energy now is through the burning of fossil fuels. So that would be coal, natural gas. We also get a lot from water. So what we're going to see, and what we've already seen, is these are going down, right? As we are more and more concerned about our climate, you'll see that the use of coal, natural gas, these fossil fuels, which pollute our air and also put a lot of carbon dioxide in our air, are going down. Well then, if we're using more energy, what has to be going up? Well, if you look here, solar has taken off. So solar, the PV is photovoltaic cells, and I'll talk about that in a minute. But also notice wind. Wind has really started to take off too as a means of providing energy for us. So in this video, I'm going to focus on the two, right, solar and wind, that really seem to be picking up steam, right? No pun intended. Okay, so let's start with solar. So a solar panel is what provides us solar energy. Well, what's a solar panel? Okay, solar panel is just an assembly of photovoltaic solar cells. Okay, that's a lot of words, Herder. Photo, light, voltaic, right? Light providing some volts for us, some energy. And that's getting it from the sun and then these little cells. So, solar panels will capture the sunlight from radiant energy from the sun, remember that big nuclear reaction that's creating lots of energy, and we'll convert it into electrical energy in the form of some current. That current then, of course, will go into our house and is often inverted to something else. But this is the basics. So how does this work? So here's a photovoltaic solar cell. If you put a bunch of these solar cells together, it creates a solar module. But what's probably on your house, if you have solar energy, would be a solar panel, which is basically a collection of solar modules, which is a collection of solar cells that are photovoltaic. Okay, so how does this work? How can you just put some, photovoltaic cells on your roof and all of a sudden, it runs your toaster? Well, it's actually quite complicated, and it's a modern engineering marvel. So I want to go into a little bit of the science of this because this is really, I think, a lot of our future. So what is a photovoltaic cell? Basically, a photovoltaic cell is made of a semiconducting material, right? So it semiconducts, right? So a little bit of conduction of the energy. Mostly that's silicon that's used today. If you are ever looking at a schematic drawing and you see something like this is just the symbol for a photovoltaic cell. So what's happening? All right, so we talk about our sun sending all this light. What it does is it excites the electrons in those photovoltaic cells, right? Much like if you remember photosynthesis from one of my other videos, if you're watching my AP Bio collection. Photosynthesis works in a kind of similar way. The sun, the photons excite the electrons in chlorophyll, and it goes down this electron transport chain, etc. Well, in solar panels, the light actually is exciting electrons again. It's just not going through a organic substance like it is in a plant. All right, so here is basically a diagram of what's happening. I'm going to try to explain this to you. It's a little engineering-ish, right? So if you're not a physics or an engineer person, I'll do my best to explain this. So silicon, which I told you is what makes up most of these photovoltaic cells, is doped with other chemicals. All right, so what does that do when we dope it? Basically, we're taking some other chemicals here, you can see some represented there, to create a p-n junction. All right, that's a term we've not heard. What is a p-n junction? Well, a p-n junction is really just a positive, negative junction. P-n. So in other words, there's a positive side, the anode. There's a negative side, the cathode. And what we're really doing is creating a place where electrons will be able to only flow in one direction. Well, what is electron flow? Well, if you think about it, electron flow is really just electricity, okay? So what happens is, okay, so here's my diagram, right? So you've got all of this silicon here, okay? And then it's got another little coat here and then an anti-reflection layer, if you think about that. Anti-reflection. We don't want it to reflect. We actually want the sun to be absorbed. So it's got this layer here. It absorbs the photons of light. And what happens is, because there's this negative up here and positive terminal down here, these electrons will want to flow from negative to positive. Well, what we've done is in this junction, we've created these small holes so that the electrons can only go in one direction. So as the electrons flow, they flow through these small holes, and you see it's creating some voltage there, okay? So these photovoltaic cells really just work by getting the electrons excited, moving them through these junctions, creating that electrical flow or that electricity. Okay, so solar's huge. What about wind? Wind is also on the rise. So natural wind flow, right? We don't control the wind, right? That's just what's happening naturally on our planet because of different areas of pressure. So what happens is that we can harness that natural wind to turn wind turbines and create electricity, right? So you see some there. The ocean is a great place to get them because areas where winds are stronger, often offshore and higher altitudes, are preferred locations. So that's why you'll see a lot of these wind turbines being built in offshore and then also places up really high or where there's a lot of wind. This map right here, which I got to show you places where there's a lot of wind. So wind power density is what this is measured in. The blue or the light blue, not much, right? So that's probably why you're not going to see a lot of wind turbines here or here or here, because it's just not much wind. But you're going to see them along coasts, right? And look at this. Look up here in Greenland. Look at all that huge potential of wind energy. Now, there's some other problems with getting all our wind energy up there, of course. It's so cold. But there's lots of potential around the world to get a lot of wind energy. We've just got to be creative in how we're building these turbines. Okay, so what has been the trend? So from about 2000 to 2021-22, you can see there's been a huge increase in the number of terawatts per hour or energy that we're getting. And this is broken down by region. So what you'll see here, North America is here, it's this line. We've definitely had an increase in our amount, but it hasn't been nearly like the Asia Pacific and Europe has had. Middle East is even less as you get up there. But what you do notice is a huge trend upwards. We're really starting to harness the power of wind energy a lot more. Now, how does this work? Well, these wind turbines can be used or fashioned in a few different ways. So I've got this little diagram, this little moving diagram here of different types of wind turbines. Some of them use a vertical axis. Some of them use a horizontal axis. So a vertical axis wind turbine, VAWT, is something that looks like this and this. So it's harnessing the power of the air vertically. Most of the ones you see are really these horizontals. So it's getting the power of the wind horizontally to turn that turbine. So innovations over the past few years have dramatically increased the power. If you notice in the 1990s, we're getting roughly 50 kilowatts of energy per wind turbine. But today and even in 2016, that has gone up huge amount in terms of how much energy we're actually getting from these wind turbines, okay? And these new materials that we're using, better science about this, I expect this trend to only continue. All right, so how does it work? Well, the components in a wind turbine are basically these blades that you see there, right? It's like a fan blade. There's also a rotor. The rotor is this assembly part here. The rotor then attaches to these gearboxes, which attach to a generator. So as this turns, and the generator then, as it's turning, that movement creates the flow of electrons, or basically energy that we can use, electricity we can use to store, to harness, to use for our needs. Okay, so solar, wind energy, big increases we've seen around our planet. So I want to end this short video with a few innovations and then talk about where I think we're headed. So I just want to show you a few really cool things. This boat is Planet Solar. It was really the first boat to circumnavigate the globe completely on solar power. So you can see a lot of solar panels stuck up there, right? That's pretty cool. Imagine being able to completely go around the world just using the sun's energy. One thing I haven't talked about is biodiesel. We've not really seen a huge increase in the use of biodiesel or biomass products, although we certainly may. But this is a bus that runs on soybean diesel, right? So this is from Nebraska. I guess they grow a lot of soybeans there. So they're powering this bus with the use of biomass or organic material that we can grow and renew. This is one of the biggest hydroelectric plants. This is the Three Gorges Dam in China, which is really harnessing that hydroelectric power from the water. And I wanted to also show you one of the biggest actually the biggest solar park in the world. It's located in India. Now you may be looking at that because the picture is hard to really tell, but you may say, oh, that's not that big. But if you look at this little scale here, that's a kilometer. So I don't know. This is probably 10 kilometers, which is, if you, in the United States and we don't do kilometers, right? It's probably, I don't know, 7, 8 miles. Same thing. So think miles. Think how far it takes you to go that many miles and see how big this thing truly is. For reference, you can't even really see it, but when you really zoom in, there's like a little car there. There's like a little building there. This thing is massive, okay? And the more we build these solar parks, the more our energy can be converted to using and harnessing the sun's natural radiant energy. Okay, so I've talked in this video a lot about innovations. Is there a downside to some of this? Well, with everything, there are pros and cons, right? Solar costs a lot of money, although the price has gone way down, but it also creates some waste on our planet, and it's using a lot of rare earth minerals. So while we're harnessing a lot of free energy from the sun, it's technically not free because of all of the some non-recyclable components that go into making these panels. Dams, right? They can create some energy, but not a lot. Wind, as we saw in Texas a few years ago, the wind is a great source of energy, but unless we're designing them to be able to withstand really cold temperatures and not get frozen, then sometimes that wind can't be harnessed at certain times. So what's the answer? Should we give up on these? Absolutely not. We just need to continue to innovate until we actually get these products and these technologies to be able to fully and efficiently provide us all the energy we need on our globe. Because the rate at which we're pulling up fossil fuels and putting carbon dioxide in the air, we know climate scientists will tell us is unsustainable. So it's really about these innovations leading us forward to change the use of energy on our planet.